Okay, your mock paper, November 2018, Edexcel, and this is paper 3, questions 15, and we'll see how far we get towards the end. So prove algebraically that the difference, so that's going to be a takeaway, between the squares of any two consecutive odd numbers is always a multiple of 8. So you should get the first mark on this. The first mark is for two consecutive odd numbers. So I know that an even number can be represented as 2x. That's clearly even because it's got a factor of 2, where x is a whole number. So an odd number must be one more than that. Okay, or one less than that. So my two numbers are going to be that one and 2x minus 1. Okay, so now it says the difference between the squares of any two consecutive odd numbers. So I'm going to put in my 2x minus 1 there, and my 2x plus 1 there. And what I'm saying, let's work on this and try and show that this turns into a multiple of 8, so I can pull an 8 out. Basically what you do with this is you just work on it. So over here somewhere I'm going to do 2x minus 1, 2x minus 1, and I'm going to grid it again. 4x squared minus 2x minus 2x plus 1. So I've got 4x minus 4x squared minus 4x plus 1, and then I've still got this takeaway, and I'm not going to draw the grid again because if I just change this, I've then got plus 2x, and that's still a plus. So it would be 4x squared, and I'm going to keep brackets around this. This is really important because all of these things are going to be taken away, not just the first thing. And plus 4x, and then I'm going to get plus 1 there. Okay, so that is 4x squared, take away 4x, plus 1, minus 4x squared, minus 4x, and take away 1. So we all know that plus 1 take away 1 cancels out. Plus 1 take away 1 is nothing. So what have we got left? We've got a plus 4x squared and a minus 4x squared. Well, clearly those two cancel out as well. So what have we got? We've got minus 8x. This has a factor of 8, so is a multiple of 8. And there was a couple of easy marks here, and then it got more difficult, I think. So first mark is for the expression for an odd number, so you can have either of those two there. The second mark is for expanding one of these correctly, I think. Yeah, for expanding there. So that's mark number 2. Mark number 3 is for, and these are actually all communication marks because it's a proof. And the last mark is for getting to a multiple of 8. So there we go, multiple of 8. So probably all maths you can do. Probably worth a bit of practice, those type of questions, because you should certainly get the first mark on those. Okay, moving on. So here is a shaded shape. The shape is made from a triangle and the sector of a circle, centre O. So that's the centre, kind of makes sense. And the radius is 6. So that's 6 centimetres. That's also 6 centimetres. OCD is a straight line. AD, this time they haven't put them on the diagram. So I'll do that. I'll tick that bit. Tick that bit. And then I've got an angle AOD. It's 140 degrees. That seems right. OAD is 24 degrees. Okay, tick. So before I even work anything out here, I can definitely work that one out. They add up to 164. So you can use your calculator, but it makes that 16 degrees. So I'm going to put that on the diagram, again getting something out of my head quick. Calculate the perimeter of the shape. Okay, so calculate the perimeter, and you've got to give your answer 3 sig figs again. They seem to have got obsessed with that, this question paper. So the first thing I could do is I think the easiest thing is to do the circle. So if I come round here, if that's 140, this must be 220 degrees, because they add up to 360 altogether. So I might work that, I can work out this circumference of that. So this is, we know circumference is pi d, or 2 pi r, depending on how you think about it. And in this case we don't want the full bit, we want the curved edge of this, which is a fraction of that. It's 220 parts out of the whole 360 circle. And then we're going to times that by pi, and then we're going to times that by the diameter, which the radius is 6, so the diameter is 12. And put that in our calculator. So we've got there So I'm going to write that as decimals because I think you're happier with that. You could leave it as a third, but we'll write it down like that for now. I'm going to write it to 4 significant figures, maybe even 5, and keep that for later. I think that's accurate enough for what we need if I leave it with the 5 decimal places that I can put back in again. Okay, so now the more complicated bit, this at the bottom here. So I've got my 14, I can add that on easily, but I need this little extra bit here. So the way I'm going to do that is I'm going to use one of my circle theorems. If this comes out to a tangent, hang on, it's not a tangent, is it? So it's I'm going to have to use advanced trigonometry instead. It's not a tangent. This is clearly not a tangent. So yeah, we're going to have to use advanced trigonometry. So we're just going to look at that circle. Now what I normally do, especially on exam day, is, you've heard me talk about this, is I try and take as much stuff out of my working memory as possible. So I'm going to draw that little triangle, 140 degrees, 24 degrees, 16 degrees. And what else have we got? We've got 6 there, 14 there. It starts to feel a bit easier when I do that, because on an exam day your mind will be slightly cluttered, everybody's is. So now I can see a little bit better. It's not a right angled triangle, so I'm thinking of one of my rules. The one I'm going to use is sine rule. So I'm going to work out a length, so I'm going to say A over sine A, little a, over sine A is equal to B over sine B. Part of the advanced trigonometry rules you know. So I'm going to call this A. In fact, no, I'm going to call this A, and so this will be capital A, and because they've got to be opposite each other, and this will be, let's go with this one, this will be B, and this will be the capital B. So let's put them in. A over sine of 24 degrees is going to be equal to B, where's B? 14 over sine of 140 degrees. So one step away from being able to put this in my calculator. If I just times by sine of 24 degrees, that'll give me A is equal to 14 sine of 24 degrees over sine of 140 degrees. The other way you could do that, if you're not very happy with this multiplying and it turning up on the top, is you could evaluate this. So the second method would be to say A sine of 24 degrees, and then you could find out what that is. What the other side is. So you could put 14 into your calculator. So we've got 14 over sine of 24, which gives me 34.4203 ... Shouldn't write over, you can't see, shouldn't write over on the side of the page because I'll get in, the examiner won't see it, and then I could then times that by sine of 24 degrees. It's up to you how you want to do it. Both ways will work. So I'm now going to times by sine of 24, which gives me A is equal to 14. Now, is that totally correct? Hang on a second. There's an error there. Let's just go back. I think I've typed this in wrong. You probably spotted this as I did it. Let's just double check. So we've got (14) over sine of 140 degrees 21. I thought I'd got it wrong. Then you'd end up timesing that answer by sine of 24, which gives me 8.8587 ... So then I need to get my full answer, so I'm going to add this. So I need the full perimeter. So this curved edge was, in fact, let's start with this length we just worked out. So we just worked out this length here. So if I'm going to take away 6 from that and just be left with this bit, take away 6 equals 2.85877 ... So I'm going to then add that to 14, because I'm going around this way, and then I need to add it to the curve, which is, I've written down to an OK degree of accuracy, 23.0. And I would write down what I've added. I would write down that I'd done 2.85877 plus 14 plus my 23.03834, and that gives me a final answer of 39.897 ... Round that off, 1, 2, 3 significant figures. it rounds up to be 39.9 centimetres. Let's have a look at what our method is for. Process number 1 for finding the fraction of the circle needed. Process number 2 is for using sine rule to work out your using your sine rule there. So that's process number 2. Process number 3 is getting at 8.8. Process number 4 is for adding them all together, and then you get an accuracy mark at the end as well there. Good example of a question that can seem overwhelming, and then you break it down and actually most of the parts are doable. Okay, the table shows information about the distances 570 students travel, so that might be useful for me. What have I got to do here? So I've got they're grouped again, 0 to 20, 20 to 50, and there are 120 students who travel between 0 and 20 miles to their university, open day. So draw a histogram. This is not a disguised question, it's actually quite a nice one. What you have to work out for histograms is frequency, density. And it's as it sounds, it's the class width, which in this case is 20, and this is 30, and normally they're different widths. And this is 30, 150 take away 80, 70, and 200 take away 150 is 50. So I'm going to divide this amount by that class width, so I can see how spread out the data is. So that will give me 6, and then I've got 90 divided by 30, it's going to give me 3. 120 divided by 30, give me 4. 140 divided by 70 gives me 2, and 100 divided by 50 also gives me 2. Some really nice numbers. So even though it's a late question in the paper, it's one which is doable. So now I know that my frequency density needs to go up to 6. 1, 2, 3, 4. That doesn't work, so let's go 1, 2, 3, 4, 5, 6, 7, 8. So the category 0 to 20 is going to be 6 high. 0 to 20. So this is 50. That'll be 25. So I'm going up to there. 0 to 20. That category will be 6. Use a ruler for this. I don't know why I haven't got one. Category 2, up to 50. He's going to go as high as 3. Um, 50 to 80. So we're going to say 90, 80. He's going to go up to 4. And then 1 up to 150, and that will give us 2, and then up to 200, that will give us 2 as well. There we go. Okay, and this was a bit of a surprise to me. When you thought students travelling to university, it seemed like lots of them had travelled miles, and they had. But relatively, most people had travelled a short distance, and then it got, well, that was a bit of a blip, but then it got gradually lower. So that would be my 3 marks. I think one of the marks is for writing frequency density. Let's just remind myself, what have we got? histogram, fully correct histogram with the correct heights. That's one of the marks. Oh, that's for all 3 marks. You could get 1 mark for at least 2 correct blocks of different widths. So it was all about how accurate you were with that. Estimate the median difference. So the median, think about how many pieces of data there are. 570. Let's divide that by 2 to give us an estimate of the median, because this is an estimate. You don't need to add 1 because it's only an estimate that I'm doing here. So this gives us 285. Let's double check that on a calculator because it's an exam day. Divided by 2 gives us 285th. So I need a 285th piece of data here. So I've got 120 so far, add 90 on, 210 so far, and then this one goes up to 330. So it's got to be in category 50 to 80. So I might write that in category 50 to 80. And how far along will it be? So I can think about how far along it would be from there. So it needs to be another 75 along. So it needs to be 75 out of that 120 along. And the category is, this is a little bit tricky actually, is 30 wide. So I'm going to times it by 30. So that gives me 75 divided by 120 times my answer by 30 gives me 18.75 into that category. So then I'd add that to how far I've already got, the 50, giving me 68.75 as my estimate. And I could get anything between 66 and 71. So that's my estimate of the median. That's tricky. I wouldn't spend too much time trying to understand that one. Unless you're particularly interested, and I'm happy to talk to you about that when we get back.